Welcome everybody. We're just going to give everyone a minute to join and then we'll start this session. Okay, great. I can see we've got lots of people joining from all over. Welcome everyone, and thank you for attending our webinar. So today we're going to be talking about auditing your airport apron for compliance, and we're going to take you through a practical step-by-step guide. So for anyone who hasn't joined one of our webinars before, just a little bit of protocol. Everyone's muted. If you have any questions, please type them into the Q&A section and we'll try and answer them as we go along. You'll receive a follow-up email with a link to watch the recording and any resources that we mentioned throughout the presentation. We also ask you to fill in a little survey at the end, just because we'd like to know how we've done today and any topics you'd like us to cover in the future. So today, we're going to have a quick introduction with our presenters. And for any of you that don't know us, a little bit about Midstream Lighting. And then we're going to take you through the step-by-step guide, which should be a roughly 30 minutes. And at the end, we'll have lots of time to answer any questions that you have for us. So, for anyone who doesn't know me, my name's Sophie and I'm Digital Marketing Manager here at Midstream Lighting. But more importantly, our presenter, Yuli. Yuli, do you want to introduce yourself?
Good morning, good afternoon, good evening to everybody who's on the call. Some really familiar names and faces on here today, so glad to have you. So I am Yuli Grigg, I'm the Commercial Director of Midstream Lighting, and I've been involved with the aviation sector really from the very foundation of the business. One of our core sectors, of course, is aviation. The first sector that we ever worked in was aviation. So I've had the pleasure and the privilege on working and delivering over 100 airport projects around the world, having been to site, having worked with stakeholders across the whole value chain. We've learned a lot and we would love to share some of those learnings with you.
Thank you, Yuli. And we've also got Marco here with us to answer any of your more technical questions. Marco, do you want to introduce yourself?
Yes, thank you, Sophie. Hello, everyone. I'm Marco Cavallotti, the project manager here at Midstream Lighting. I've joined the company over 6 years ago as a pure, let's say, lighting designer. And within this year, I had the opportunity to develop a lot of skills in not just the design, but I had the opportunity to go and visit more than 100 installation sites, being side by side from the very beginning of the project, so from very basic input information from customer to the end installation and to the commissioning as well.
I think it's probably safe to say, Marco, that there's nobody out there who's more experienced in designing and delivering apron projects.
Yeah.
You've worked on thousands, and your team has worked on thousands of projects.
Oh yes.
Customers. And you do site commissioning and installing these things from civil aviation to military all over the world. So, I think that's definitely great experience we're going to be able to share with our friends, customers, and partners.
Yes, I've been in contact with actually some of the people which I'm seeing they're joining the webinar, and been on site with them. And so I mean, yeah, this is the.
I've just noticed we have.
Background.
Yeah, I've just noticed we have someone joining from New Zealand. That's very impressive because of the time difference. So thank you for your interest and support.
Fantastic.
So back to you, Sophie.
No, thank you. So for anyone who doesn't know us, we're Midstream Lighting and we're a full cycle turnkey specialist manufacturer of high powered LED flood lighting systems and solutions. And what that means for you is that we're there for you throughout the whole project. We don't just give you the product, we help you right from the start with our fantastic lighting designs with Marco and his team to help you find the best solution for you. We help with any rebates and incentives that are out there to help you finance your products. And we really pride ourselves in training and educating others as well. We're specialists, not generalists. We work in only our 4 key sectors: aviation, maritime, sports and horticulture. And we really do know these sectors well. And we started all this in 2010. We manufacture our lighting products in the UK and Romania, and we export them globally. And we're really proud to have our amazing R&D and technical office based in Milan, where Marco is right now. And our aim is not just to be a manufacturer, but really to be a thought leader. We want to share our knowledge with all of you, and that's why we're doing this session today and why we're going to keep doing these sessions. So now I'm going to hand over to Yuli, our expert on all things apron lighting. So Yuli, over to you.
Thanks very much, Soph. So I think the first question that we always like to pose is, why should all airports care about apron lighting measurements? Why is that important? Why is this topic of interest at all? I think we have to remember that the apron area predominantly is the place in the airport where passengers and cargo embark and disembark the aircraft, and there's fueling, there's various types of operations. So lighting provides a safe environment for passengers, but also for operators, for the staff, for inspectors or third-party persons that may be on the airport apron. Now, apart from the fact that that's an element of safety and safe work environment, airports have to conform to legislation and also regulation, globally. So there are always regulations that mandate the minimum level of lighting on airport aprons. And we'll talk a little bit about what they are in the next couple of slides. But beyond the basic duty, which is to allow safe and efficient operation of the airport, passenger movement, aircraft handling, CCTV, security, ground services, all of these services are core offering of the airport, and therefore lighting provides a good lighting provides a more efficient way of delivering those core services. So it's not just a requirement, but it's something that's important for an airport to provide for efficient operation.
Fantastic.
I think we have a poll.
Yes, we do. So before we get started, we just want to know what you guys out there are doing at the moment. Have you audited your lighting in the last year? If you have, please let us know. I'm just going to give you 30 seconds to answer the poll.
This is in the last 12 months, right, Sophie? This is
yes.
Not, yeah, so.
Yeah.
I think we're looking to see how many operators, or if you are, for example, it's not relevant to you, if you are a consultant, then your customer, how often are they doing that you're aware of? So are they doing that on an annual basis? Is that an ad hoc a check, or do they do that every 6 months?
Okay. So we can see, wow, 21% of you have done it and you've passed. You're meeting all the required levels. 15% of you have done it, but you're not quite there. But a massive 64% of you haven't audited in the last 12 months. Yeah,
hopefully that, but then, some of those are going to be not relevant to us, or, partners and things that have answered no. But interesting that 21% do meet the required levels, because I think, Marco, if we look back over the last 6 or 7 years, the majority of the airports were not meeting their requirement, the ICAO recommendations. And so that's already a good improvement that 1 in 5, at least according to this poll, actually do. Good. Okay, so let's carry on with the presentation. So why did we compile this guide? Well, very briefly, we did this because the airport operators that we have been talking to over the years have not always been sure of what their obligations are. And it's not a topic that's often covered by training providers. You can go on courses for AGL, and that's well serviced. But apron floodlighting is something that's typically overlooked by training providers, and therefore knowledge is really missing. And also, there's no global sort of guidance which people can pick up and refer to. There is, of course, the ICAO recommendation, but that just is the standard, and it's not very clear how do we put that into practice. Airfield operations or maintenance departments or others, they're not really provided with a clear methodology, and therefore, to run it is complicated. Do we follow the same methodology? If we haven't got one, how do we always do it in the same way? How do we compare the past with the present? So those are the questions that are typically coming up. And normally, what we found at airports, there's no historic record of what they've been doing before. So if we don't know what's been happening in the past, we can't see the trajectory. We can't see or forecast the future, and that's especially difficult for scheduled maintenance. We all want to move away from reactive maintenance and move into the scheduled maintenance world, and therefore ongoing and regular checking will be helping us to do that in the right way. So that's why we did it. What are we basing it on? So what regulation is there? Well, all requirements typically stem from ICAO Annex 14, and these are recommendations. They're not rules. ICAO doesn't mandate this onto anybody. But what these recommendations are basically the framework, which is then adopted by each country's national civil aviation authority. It could be a health and safety agency. It might even be a standards agency. But all of these are what we call the competent authorities. So each country will have the competent authority that converts those ICAO recommendations into a legal requirement. Okay, so in the end, each country will have that competent authority which oversees the compliance to their recommendations in ICAO. And in some cases, it may choose to exceed those. So we have seen instances where the competent authority in the country have said, we would like to improve on the levels that are mandated in ICAO. And if anybody wants real world case examples about that, then you can contact me or ask, and then we'll cover that in the Q&A section. So if we then look at ICAO and see what does it say, okay? So if we turn to Annex 14 and we turn to the right section, which talks about it, and here we're using the 8th edition, July 2018. But they don't change and haven't changed for years. They may change in the future, but we haven't heard from ICAO that they're planning to do so. And the recommendations are this. Okay, it's a recommendation that the average illuminance, and please note this is not the minimum, this is the average illuminance, should be at least the following on the aircraft stand. And also this is quite important, that the aircraft stand means we need to measure and provide the lux levels for each aircraft stand independently. We're not talking about the aircraft apron area. It specifically talks about the aircraft stand. And it says the horizontal illuminance should be 20 lux with a uniformity ratio, which is the average to minimum, of not exceeding 4:1. Okay, so the other way to look at it is 0.25. It's a quarter, yeah, 4:1. Vertical illuminance, just as important. And I also know there are airports that we have talked to that don't measure vertical illuminance, but it is important. And you can fail vertical illuminance even if you pass on the horizontal, okay? So the vertical illuminance must be 20 lux, measured at a height of 2 meters above the apron in relevant directions. Yeah, very ambiguous, and we do talk about that later. And then another important point is that the other apron areas should cover horizontal illuminance, which is 50% of the average of the aircraft stands, and also meeting uniformity requirement. Some points to note: the vertical illuminance, for example, doesn't require a measurement of uniformity. So the horizontal should be 4:1, but vertical is not a requirement, although it is best practice and something that we try to always work towards whenever we work in projects. Average illuminance, again, we mentioned, and I need to reinforce this, means average lux values. It doesn't mean the minimum values. And we still, today have that discussion with contractors or airport operators. It is the average values, which should not be. So the minimum average. And then uniformity should not exceed the ratio of 4:1. Therefore, the maximum, minimum, and the average values all play an important role during this measurement. Okay, so that uniformity can be thrown out if you have a very high level of light in a certain area of the aircraft stand. So hotspots or symmetric optics can cause a problem with uniformity. And again, any questions around that we can tackle further down the line. So just to mention that the North American market, and I don't think we have too many partners on here from North America because of the time difference. But just to say very briefly, that's covered by the IAS RP37, which is a recommended practice. Interestingly enough, it's not a regulation, it's a recommended practice, but it in fact follows the ICAO recommendations. I think we should remember that the US system uses foot candles as opposed to lux levels, and but they're pretty similar. So as a rule of thumb, 2 foot candles means 20 lux. So you have to basically divide the foot candle by, multiply the foot candle by 10 to get to lux. Okay. The European market, okay, so this actually is a legal requirement in Europe, and this came through the European Aviation Safety Agency, and it's binding on all EU member states, okay, so this is a law. The real information is found in ADR DSN, which is basically Aerodrome Design Book 1, Chapter M, and then if you follow that, you can get to what it is, but basically the requirements are in line with ICAO Annex 14, which we discussed earlier. In addition to the ASA requirements, members in the EU are also bound by the European standard EN 12464, which is basically outdoor workplaces. And it talks about the terminal apron as well as the hangar apron. And these are required to have an average of 20 lux and a uniformity ratio of 0.24, which is basically 4:1. So it's the same, and you've got 2 pieces of legislation there that are binding on European members. Other aviation markets, so UK is now out of the European Union. So we in the UK here follow CAP 168, which is published by the Civil Aviation Authority. Australian standards are called the MOS 139 aerodromes. New Zealand here has an advisory circular, AC 139-6. The latest revision that we're aware of is revision 5, 2016, but our colleagues from New Zealand can let us know if that's been updated recently. Russia, for example, has several guiding documents. The primary is the Ministry of Transport, Federal Aviation Rules. Kazakhstan will have its own ministry rules as well. We've just been working on the project there. So, you know, this is again the adaptation of the ICAO rules into each country, perhaps into its own language, and then using that as a basis for the legal requirements to comply with on the airport as part of the licensing rules. So anyway, there is a more detailed overview of the design parameters that can be found in Doc 9157. In chapter 13, apron floodlighting, that talks a little bit more about designing and things like that. So if anybody's interested, they can look towards that document as well to get a little bit more information. So now we move quickly into the process, the preparation. Okay, so now this is where we are going to be talking about the practical elements. Pre-check considerations. Okay, so these are some of the things that we need to think about before we start going out to the apron and measuring. Okay, and the main considerations are this: a number of measuring points. Okay, so measuring lighting levels is not a quick process. It is time consuming. It needs to happen at night time for obvious reasons. It needs to happen on the clear stand, so there should be no aircraft. Therefore, we can't spend hours and days on this. Okay, we have to be practical in how much time we spend. So for that reason, we've adopted the United Kingdom's CAA approach, which is 15 measuring points for smaller stands, and extended that to 25 measuring points for larger stands, because due to the practical implications at night, you can't be there measuring 100 points. Clearly, the more measuring points you have, the more accurate results. But we found, working with a number of aviation authorities, that the 15 and 25 points is enough to understand the state of the lighting on the apron. Okay, so that's the first point, the number of measuring points. The second point is we have to secure the area. Okay, so we mustn't be in a position where we're measuring and an aircraft is coming to disembark on that stand, or vehicles are coming along, or there's an air bridge. So, when submitting a lux level testing plan, we have to get that coordinated with airside operations and also the ATC, right? It's better, if possible, to move the air bridge out to avoid the shadows, and the stand should be completely clear from aircraft or vehicles. So some coordination is really required with ops and ATC. Then we have to select our illuminance grid. Okay, so and the next few slides will show how we do that. But basically, it's not willy-nilly. We don't just decide how we do it because that's how we feel. We do follow a standard. And this standard is clearly laid out again in outdoor workplaces, European Normative 12464, under the section Illuminance Grid. Okay, and the grid system should be created for this task specifically and the surrounding areas to indicate the points at which the illuminance values are calculated and then verified. Because remember, ultimately, what we are trying to do is to understand the state of the lighting, but also how does that correspond to the initial design that we have on file whenever we install our system, be it previously conventional lighting with metal halide or sodium, high pressure sodium, or whether it's with the new LED technology, or some airports have gone, and tried other technologies like plasma and things like that. So, grids approximating a square preferred, and the ratio of the length to the width of a grid cell should be kept between 0.5 and 2. And there's also something we need to have a look at, which is the standard 12193. But the maximum grid size is basically along this formula, and then the formula continues, and therefore we get to a grid, which we're going to show you in a minute. And I think that we can look into that more if there's requirement for that, and if there are questions on that specific grid, we can discuss it towards the end. We also have to consider the size and stand type. Okay, it's because not every airport will have markings on their apron, will not have clearly laid out stands. So if the apron does not have stand markings, we have to select the correct aircraft size and stand type. And this is usually done by selecting the largest aircraft that can be received on that particular stand. So we have a look at the aircraft, we understand the wingspan, we understand the length. We can work out what type of code A to code F aircraft stand it will be. And then we need some equipment. So we'll need a calibrated light meter, an LED calibrated light meter if you're using LED lighting. You'll need a measuring wheel or a measuring stick to mark out the points. Ideally, we have objects to be used as a marker, for example, traffic cones. But some people use, for example, a spray paint, a temporary spray paint. Some people use some chalk to mark out the points. It doesn't matter. The point is that you have to mark out your points as you move along them to take the readings. And you should have a photometric results sheet, clearly. There's one that can be sent at the end of the presentation, which you will use to fill out the information and keep that safe before it's transferred to a Excel spreadsheet. So now that we're there, we have to take the light readings. How do we do that? Okay, so the light meter, or the lux meter, it's actually a sensitive device. And so, there are some best practices about that, actually. It's important to use a reputable brand. Lux meters, they need to have an F1 value better than 3%. It's worth noting that lux meters should be calibrated regularly. I mean, normally they're calibrated to an incandescent source, to a tungsten, but if you've got LEDs, then let's make sure that that's calibrated to that particular spectrum where you have a much higher peak of blue. And it needs to be calibrated with 12 months. And also it's making sure that we're using the correct scale. So we've had some instances where people have turned them on and said, well, I'm only getting 2 lux or 0.2 lux, actually, just change the scale to make sure it's the correct one. So I think we have another poll, Sophie.
We do.
Okay.
Yeah. So we wanted to know if you guys get your light meters calibrated every year. And we'll just give you 30 seconds to answer these. Interesting.
Let's see the results.
Okay, so 31% of you do, and you have LED lighting, and another 20% if you do with your older system. So over half of you are getting your meters calibrated every year, which is great.
Yeah, exactly. And I think, Marco, you've been to sites as often as I have. We have found quite a wide difference between the levels that we get from a calibrated meter and one that hasn't been calibrated for a couple of years. And the swings can be in both sides. So you can have an extended high and an extended low, or a double low. So various reasons to get it wrong, basically. Okay, so thanks for that participation. And we move on to the next slide. So taking the readings. So the light meter, as mentioned, actually, no, we carry on with the horizontal readings. Yeah, so horizontal readings. This is the simple one, where the horizontal is measured on the floor at basically 0 meters, unless it's a military installation, in which case quite often it's recommended to do the horizontal at 2 meters. So in that case, you need a tripod. But in most civil aviation applications, horizontal readings are best placed on the floor with the receptor flat to the ground. We should leave the receptor in place for about 5 seconds for the readings to stabilize. So don't just have a look at it, write down the first number and move on. Wait for it to stabilize, 3 or 4 or 5 seconds, usually enough, and then we record the value. What we have to make sure, though, is that we are not leaning over the meter, that nobody's standing behind us, that someone's arm isn't creating a big shadow over the actual receptor. Some light meters are built into, with the receptors built into the light meter, so that's a bit more challenging, because for you to be able to see the value, you need to come approach it, and quite often you can create a shadow. Some light meters have a receptor further away from the actual meter, and that's a little bit better, because you can see the readings without leaning over the receptor. But this is a really critical point, and we've seen many instances where, done incorrectly, you can get the most wild results on your readings. Now, for vertical readings, this is important to comply for the ICAO, shouldn't be overlooked, and these are taken at 2 meters above the apron in relevant directions. So you'll need a tripod to make sure it's always at 2 meters. And it's really as simple as that. So it'll always be facing, well, there are 2 ways to do this. And this is, I think, where we talk about on the next slide. Vertical readings, there are 2 versions to interpret the relevant directions. Version 1 is where we have one direction with a lux meter receptor facing the head of the stand. Okay, so that's a 90-degree angle to the ground. So if we're standing in front of standing on the apron, okay, and we see that the head of the apron is in front of us, we keep the light meter up like this towards the head of stand at 2 meters higher, compared to the previous horizontal, which is on the floor like this. So those are the 2 differences. The second version to interpret the relevant directions, and notice the S at the end of directions, making it plural. The other way is to do it perpendicular to the aircraft stand, 2.5 meters in each direction from the center line. So we take the center line of the aircraft stand, 2.5 meters in each direction, facing away from the center line towards the edge of the line. So horizontal, vertical, option 1, horizontal, and 2 verticals perpendicular, I'm trying to get my hand, perpendicular, like this, to the fuselage of the aircraft in 2 directions. And then we talk a little bit about this in the next couple of slides. So once we've identified how we're going to do that, the next step, of course, is to select the correct aircraft stand category. So one airport may have different aircraft stand markings from another. So this guide refers to the use of aircraft stand codes under ICAO. FAA in America use design groups as a main reference point, so it's a little bit different. But ultimately, an aircraft stand size code or group will be determined by the largest aircraft that it can receive. Okay, so therefore code A or group 1 is designed for the smallest, and code F is designed for the largest aircraft. That's group 6 under the FAA. Additionally, it's possible to use the wingspan of the largest aircraft to identify the width of the aircraft stand, and therefore use that to identify the category. So if we don't know how long it is, we'll just use the wingspan. So, and also, if there are no stand markings, just assume the T line as a stand center line, and we'll use that as the main reference point. So to calculate the aircraft stand width and length, there is a table which we can, which is provided in our guide, and that's based on largest aircraft stand, and we can use that to do it. So the next section is aircraft stand light reading. So this is where we go into the nitty-gritty, as they say, in some parts of the world, and aircraft stand light readings. So here we are. This is the step-by-step guide that I'm going to just run through briefly. We're about 30 minutes in, so I think we're doing okay for time, but I'm just going to speed up a little bit. So here you see the top of the center line, okay, and that is the T, okay? So the T is the top of the center line. That's where we start our measurements, from the top, and so therefore the measurement from the top of the stand, which is above the T-bar. Yeah, so we have to consider the top and the bottom part, okay, where the aircraft stands. We divide the total length of the aircraft into 6 equal parts. Okay, so depending on the length, it's 1/6 all the way to 6/6, and the marker will be positioned on each of the 5 dividing lines. So you place a marker really between each of these lines. So 1, 2, 3, 4, 5. So, you know, in the example here, if the aircraft length is 60 meters, so if this whole length is 60 meters, then we divide it by 6, and therefore we get 10 meters. So a marker will be placed on 10, 20, 30, 40, and 50. The first and the last points are not used in the calculation. Okay, this is important. So this and so the top point and the last point are not used. So in point 3, we place these markers, C1, C2, C3, C4, and C5. Then we stand at the center line and measure the width of the left side of the center line out to the edge of the aircraft stand. Okay, so we can see the center line, then we measure the width. From the width, we can divide that into 2 equal parts and place the first left marker on the left-hand halfway point, making sure it's horizontally in line with the marker point on the center line. So we know the distance by measuring the width and dividing it by 2, and it's horizontally in line with the last point. And then we work our way up to the top. Again, each of those 5 points placed horizontally to the others. So now we have L1, which is left 1, left 2, left 3, left 4, left 5. And then we repeat the same to the right-hand side. So we take the right-hand side width, divide it in half, place the first point, and then the others. So now we have R1, R2, R3, R4, and R5. And then once we've got those set up, we take the horizontal and vertical light readings at all the left, center, and right marker positions and note them on the form. Okay, so now we have 15 measuring points. For larger aircraft stands, which are basically categories E and F, so code E and code F, that's not going to be enough. There's just not enough measuring points for quite a large stand. So, you know, the code F is sort of 80 by 80. It's not going to be enough to have just those measuring points. So instead, we're going to use 25. And again, the process is similar. We take the whole length of the aircraft stand, starting above the T-line, dividing into 60 parts, and positioning a marker in the 5 points, again, C1 to C5. Then we take the width from the center line to the edge of the aircraft stand, and we divide it into 3 equal parts. So the widths into 1/3, 1/3, 1/3. And now we place the first left marker on the first left-hand third waypoint and on the second third waypoint, and these should be horizontally in line with the first marker point. Having done that, we can place our cones or markers on the left. So now we have 5, 5, and 5, and we repeat the same to the right-hand side. So take the width, divide it into 2/3, place the 2 markers and then the rest of them, and now we have basically the center lines, C1, C2, C3, C4, and C5. And then the left 1, left 2, and right 1, right 2 positions. So now we have 25 points, which we're measuring on the larger aircraft stands. If we consider that example is using the vertical methodology of just 1 measuring point, which is at 2 meters, 90 degrees to the ground, and to the head of the stand, that's fine. If we want to consider taking a reading which is basically the double verticals, which is something that a lot of airports are starting to employ. So can you just help me to get back to page?
This one? Okay, this one.
Yeah, great, great, thank you. So this is how we would measure the double verticals, which are part of which is the one where you use the fuselage of the aircraft. So here the vertical readings can be taken 2 directions, each facing outwards, and we've shown an aircraft there, but clearly when you're doing the measurements, that's just for guidance. There should be no aircraft on the stand. We divide the total length of the largest aircraft. So just take the body of the aircraft into 10 equally spaced points, and then we position the light meter on a tripod 2 meters above the ground and take the measurements in the direction of the arrows. So left and right. So you're taking 2 measuring points for that. And these should be taken sort of around 2.5 meter distance in each direction away from the center line. So they are about 5 meters away from each other. And the reason for this is that the thinking that once you are disembarking from an aircraft, or once you are loading the aircraft, or refueling the aircraft, or taking readings or notes, or inspecting the aircraft, all of that is happening along the fuselage. And that is the critical point of where you're going to be measuring the vertical light levels. So we are not measuring them by the edge of the aircraft stand. We're measuring them in the 20 points, 10 on each side along the fuselage, and that's it. Okay, and we are aware that quite a lot of European airports are now employing this particular methodology, especially on aircraft stands which are newly redesigned or extension projects, or in fact, greenfield or new build projects. It's a little bit more difficult to employ this methodology for existing aircraft stands, which were initially designed with a different methodology in mind, okay, which is the previous one that we explained. So it's hard to employ that to the old design, because clearly the chances are that that will fail the compliance checks. Okay, so those are the two methods for measuring vertical levels. Now, just a few words about the service roads. We get a lot of questions about, well, okay, the service roads, they are part of the apron, therefore they need to have 50% of the light level. So, well, that's incorrect, actually. Apron flood lighting for taxiways is not covered by ICAP. Okay, so taxiways is not inside the regulation or inside the recommendation. Okay, now apron means a defined area intended to accommodate aircraft for the purposes of loading or unloading passengers, mail or cargo, fueling, parking, or maintenance. Other apron areas does not cover taxiways because you don't do any of these operations on the taxiway. Okay, so taxiways and apron routing pathways really should maintain a minimal level of lighting. Now, Doc 1957, the design manual, says this: aircraft taxiing under section 13.2.2. The pilot mainly relies on apron flood lighting when taxiing on the apron. Uniform illuminance on the pavement within the aircraft stand and elimination of glare are major requirements. On taxiways adjacent to aircraft stands, so this is maybe a taxiway behind it or through the aircraft stands, a lower illuminance is desirable in order to provide a gradual transition to the higher illuminance on the aircraft stands. Okay, so that's what that document says. If we look at another guiding document, which might be the US RP37, that section 431 aircraft stand says this: spill light from the aircraft stand is to be limited to just 5% of the average illumination in the aircraft parking position measured vertically at 2 meters, 6.6 feet above the ground at either the furthest edge of the apron service road behind the aircraft or 15 meters from the tail of the aircraft if no apron service road is present. So in essence, what we're saying is that taxiways are outside of the scope of apron floodlighting and are not covered by ICAO in that respect. See, this is an important point. Now, we're making good time. I think I have just one more slide to go before we take some questions. And I think that's great. So the next slide is about common mistakes. So these mistakes are the ones that we have come across when working with airport operators in all different locations around the world. And there are probably other common mistakes. And if anybody on the call would like to share them, we would gladly include them in the next version of the guide. So some of them are this: not matching design to the actual readings. Okay, so lux levels should always correspond to the lighting design on file. Because if we haven't got that, there's no basis from which we can correct or improve the installed system. So we need a reference point. So if they're not matching, that's a fundamental disconnect between the lighting project, whoever that's been supplied by, the contractor or a supplier or a third-party provider, or the airport itself. They need to match. So we're always checking, is the lux level data we're getting on the ground matching what we're expecting from lighting design? Okay. Another common mistake will be measuring across an apron area, grouping multiple stands. Okay, so the standards are clearly calling out for measurements across an aircraft stand individually. So if we're grouping them together, we're not doing that correctly. And from what I've seen from the work that Marco and his team of engineers are doing, is that when we are measuring it as a grouped apron, and then we divide it into individual stands, typically we find that the individual stands will not pass the requirements, even though the grouped apron does. Okay, so you can do that, and when you have an inspection by the CAA or your competent authority, you'll understand that it's not compliant because it hasn't been designed correctly. So another common error would be confusing the minimum and the minimum average. Just recently, we've been talking with a customer who still insists that the requirements are the minimum should be above 20 lux. And we are explaining that the standards call out for a minimum average. Okay, so the requirement is therefore average levels. It's not minimum of 20 lux, it's a minimum, it's an average of no less than 20. Actually, if we then look at the requirement of uniformity, we do realize that dividing that by 4, the minimum level must never be below 5. So if we are on the apron and we are measuring something on the aircraft stand and the lux levels are below 5, that means that the minimum is going to be below 5 because that's the lowest point. And it implies that we're not going to be able to meet our uniformity requirements. So therefore, we're always looking out for that lower than 5 level. Ignoring uniformity requirements. Okay, so this is quite common. High percentage of cases we've seen, the airport will just measure the average values and not pass on the uniformity, or sometimes not even measure it. So uniformity is a core requirement. You must pass both the uniformity and the average levels. One is not more important than the other. Another common mistake is that stand markings may be much larger than the largest aircraft size. So we've seen airports, actually predominantly in Asia, has been my experience in the Far East, where the aircraft stand can be 120 meters long. But the biggest aircraft it can receive, is going to be a 777. So we don't need to do the lighting design. We don't need to measure on 120 meters in length. What we do need to do is to measure it on the highest aircraft size that it can receive. So 777 will be a code E from memory. And so we then apply code E markings or virtual markings and measure it according to that. Yeah, so you mustn't take the largest markings at all. MARS. So MARS stands are basically multiple aircraft receiving stands. Sometimes people say multiple aircraft ramp system, but in essence, it's one aircraft stand that can receive multiple types of aircraft. So for example, it can receive, two A19s and one 747, or, a 380 and a Boeing 737. So when you have a stand like that, each of those types must be measured independently. So even though it looks like you have one stand inside your apron, it actually is 3 stands, and each one have to meet the lighting levels independently. I think I've seen our friends from Oman, Muscat Airport online. So that was the first time that we practically had come across this challenge, and then had to redesign and rework in order to meet those requirements for each of the little ones which were further away, had to be designed independently, and it caused some challenge. So that there are some real practical examples of that. And then not calculating individual parking positions is a common mistake. So some of these things that we've come across before. Then we've got some others here. So tilting of the lux meter. So if you hold the lux meter in your hand, as opposed to laying it flat on the ground, any degrees of tilt can give wildly different results, okay, significant. So the lux meter should always be secured either with a tripod or placed flat on the ground and left there to stabilize for a few seconds. There are instances where you have apron tilting for drainage. So that's been asked before, it can be up to 1 degree. The lux meter should be placed as flat as possible, accounting for that several degrees of tilt. Another mistake is not recording all the data. So gaps in measuring points can lead to different results, and that could fail an independent survey. Okay, so we must record all the data, even if we think that it's, that area is not well serviced by the light, or there's a missing and if there's a missing light there or a missing mast, we should record all the data. Another point about recording on a rainy day. Okay, so quite often, especially in some climates like the United Kingdom, we have lots of rainy days, monsoon season in certain countries. This can cause an inaccurate result because the raindrops can act, in fact, as a light prism, surprisingly. And also the rain can damage the lux meter, it can sit on the sensor. So, we want to avoid doing these results on rainy days, and we want to stick to days which are clear and preferably without a lot of moonlight. That's also something that we mustn't overlook. And a final mistake is recording levels in the shadows of aircraft or bridge. Okay, these are not accurate results because they are not telling us what the lighting level is and when it was designed. So we must remove those obstructions from the aircraft stand and therefore move away from that. I think that's it, Sophie. Although I did have some, I think some other statements.
Okay, well, fantastic. Thank you very much, Yuli. I've certainly learned a lot. And yeah, we've got quite a few questions. Did you want to answer some questions, or what is it you're looking for?
Listen, we've got 10 minutes.
Yes.
On that, and I think that I may just mention a couple of the best practices. So we do have something called the
it's blurred, Yuli.
it's blurred, yeah.
We'll
So your face.
Anyway, we have something called the Photometric Measurement Guide for Aircraft Stands, which is available to share. And in that guide, there are some best practices after the common mistakes, which didn't make their way into the PowerPoint. So I'll just mention them now, because I think it's important to wrap that up with the best practice. So frequency of checks, okay? Twice a year, so biannual or annual checks for all aircraft stands. That's really is the best practice. You know, larger aircraft, large airports, that will take a significant amount of time to cover the whole area. Okay, so it's almost a continuous process. You know, you could do monthly checks, doing different apron areas, Yankee stands, you know, Alpha stands. But if you have a large area to cover, just make sure that it's a continuous process. So within a year, you're covering all of the aircraft stands on the airport. Written methodology, okay, for testing. So we need to keep a methodology on file. So, you know, if your team is great and they've been there for 20 years, know what they're doing, one day they may retire, they may, you know, go on a long holiday, they may, you know, any reason why they're not there. The next person that comes in doesn't have the training, doesn't know what to do, cannot do his job efficiently. So have a written methodology, and you can use the one that we have in this guide here as your own, basically, as your own template. Always have a responsible and accountable person for apron lighting checks. Appoint them, someone who will basically own this process, somebody who's accountable for it, somebody who can go out and double check the measurements if you outsource this to a third party. So if somebody else is doing your light level checks for you, and you're not doing it in-house, somebody who can go out there and verify these things and be responsible. Keep a logbook and keep a record of all the previous levels. Okay, you can do that in the Dropbox file or whatever system you use as a digital asset. You can keep it in the written statement. But ultimately, the digital copies will allow faster checking, and you can have a look at the historical compliance. If you can see what's been happening over the years, so for example, there's a gradual decrease in lux levels, you can forecast at a certain point you're going to be non-compliant, and you can take the steps to prevent that from happening. If you're not having that trend available to analyze, it's very difficult to predict what's going to happen in the future. Keep your lux meter calibrated every year. Okay, so it's very easy to forget to do that. You know, everybody's busy, and the airport's a busy, dynamic environment. We understand that. So sometimes it's good to have a little contract with a laboratory that will send you an annual reminder. That's what we do. We get an annual reminder every year from our testing lab to say, hey, your 20 light meters, they're all due for renewal, or some are due for renewal and another recalibration, some aren't. And then we're able to obviously send them back and get them calibrated. The next point is, as a best practice, supplier submitted designs and commissioning checks. So if you brought in a supplier to design your apron lighting and to do the installation perhaps, or do the commissioning, and they're giving you the results, always double check this. Okay, this should be checked by the accountable person. It's so easy to get this wrong, to fix a couple of numbers. You see a 4, you call it a 5, and so on and so forth. Okay, because it's difficult to fix a problem once it's already installed. So in order to avoid being surprised by an inspection, always make sure that you know what's going on. If the supplier is doing compliance, go out with the supplier, go out with the installer, and check that they are correctly making the reading recordings and the data is fully recorded and properly interpreted. So of course, some airports need to be assisted by third parties, by independent surveyors. But even in those cases, even if it's a third-party company, make sure someone is accountable and responsible, checking those values, because ultimately you are responsible for ensuring that that is in compliance with regulations. And also, lux levels should be carried out after every new lighting installation. So if you've been doing your light level checks and they're fine, and you've installed some new luminaires, or you've put a new mast in place, that area should be checked and verified and added, and making sure that after that, on an annual basis, it's inspected. And then in the end, if you have problems, consult an expert. Okay, don't be on your own. It's not an island of one. There are experts there. We're always happy to help. We're just at the end of a line or an email, but there are other experts out there. They can assist you. So don't get stuck. Speak to someone who has the experience, and all of these things can be solved, whatever the problem is. And I think that's it. As someone's mentioned where this guide is, it is available. We do have on there wingspan dimensions for different aircraft types. We do have different types of aircrafts as per each of the groups of aircraft stands, depending what the group or code it is. So it's a pretty good guide, and it is available for you. That brings my presentation to a close, and we've got about 5 minutes for questions.
Thank you, Yuli. And yes, as Yuli mentioned, the guide is available on our website. We will send out a link after the webinar where you can go to get it. You can also request a physical copy if you'd like one posted to you, and we have it translated in a selection of languages as well, which you can request. So, as Yuli mentioned, we've got loads of questions to get through, but not a lot of time. So we're going to go to the most critical ones. Before the webinar, we asked if anyone had any questions, and we received one that Marco is going to answer for you now.
Oh, yeah. Thank you, Sophie. Yes, this is one of the, say, main questions we've been asked to answer. So basically, why we don't use the markings on the ground, so the back line and the top line and the side line as a reference for our ratings. Well, these, as Yulia has already explained widely during this session, is included in the norm. But the norm is not like you have to do this way using this part and these points. It's always like being a norm. I mean, a norm needs to cover tons of different places and shapes of calculation grids or task areas. So it just gives you a guide on how to do it. And in the European Standard 1246.4.2, the outdoor working places, there's a reference to this norm, the EN 12193. And we are just showing you a big, small portion of the text. This is the point 1.1.4. This is the session. And as you can see, in the session, we have showed you like a formula which defines the maximum amount of points for a given area. With this norm, which is included in the ICAO and in the EN 12464, we can see that it suggests to consider like two different quantity of points when you're calculating on the software and when you're measuring on site. One of the reasons is also the time which is needed for, I mean, to do the light checks to take the readings. And because in real life, I mean, half of the points are considered more than enough to verify the compliance with the design. So basically, this is the only scheme which is shown in every normal regulation. And as you can see, it considers like a gap between the outer lines and the first reading points, and then just half of the points to be checked on site compared to the design into the software. Let's say the majority of the software has already in their own procedure this formula, the one Yulis has showed you before. And so they always consider, let's say, the maximum amount of points possible following the norm for a given area. So when we do the light checks on site for the aprons, for example, we just consider the amount of points you divide it by half, and then it gives you like the 15 points, roughly the 15 points for small aircraft stands and 25 for the big one. So this is just maybe because this is always like a good question that the end user asked us when we do like the commissioning on site. There's a question, Yuli, coming from the Q&A box, is what about the mobile measurement system, if we recommended them or not? I would just say that for like the market offers like some good mobile measurement systems. There are like a company that do this as a main job. Of course, if you have a small airport, it's not possible to involve like a big company to do like 5 or 6 stands. If you have a procedure and you have a guide and you know how to do it, you can do it internally with your maintenance or the operational people. And of course, you don't have to do it like all the stands in the same night. You can do it like stand from 1 to 5 in the first week, and then 5 to 10, and then like rolling the checks within the year. So I don't know if you want to add anything else, Yuri, on this.
No, that's it. That's fine. I'm just going to tackle a couple of quick questions. We've got one here from Imad, who says, hello, in which standard can I see that the standard is 50 lux, not 20 lux for cargo apron? And so that's covered by the EN 12464 outside space. Under table 5.2 airports, there's something called loading areas. And for reading labels, they recommend 50 lux average. So that will be in that particular standard. Another question here, just I think we'll just have to go for the quick wins. Faizul asks, is the shadow of aircraft needed to be considered for apron lighting design? And the answer is no. Lighting design is considering no aircraft shadowing. However, what you can do is you can place the 3D models of the aircraft inside the simulation software to demonstrate to you where there will be a shadowing issue and how they can be tackled. Ultimately, an aircraft wing will always create a barrier to the light. You know, it's not translucent. Light cannot travel through the wing or through the fuselage. So obviously, there's going to be some kind of shadowing. But we've employed 3D models for some airport customers in the past to show where those shadowing problems can occur. And how much glare value is allowed is another follow-on question. Well, as little as possible, but the standards refer to a GR value of 50 or less, which is something that we can demonstrate on simulations when we submit our designs proposals to the customer.
Just another one from Faizul is minimum lux need to be maintained on GSC. As showed before by Yuli, it's 50% of the apron illumination level. And it says 50% because the recommendation is for 20 lux, but maybe you can have more than this. So 30 lux average on an apron. So the adjacent GSC area, general area, should be 50% of 30, not like 50% of the minimum requirement. So if the closer apron is 30, the GSC area should be at least 15 lux. So this
Marco,
is
let me just do one more question, and I think you can answer this because it's really difficult, and I don't know the answer, and you might not. It's by our friend Svetan from Fraport, Bulgaria, an excellent engineer indeed. He's asking, when you have we have an area covering light from sodium from one side and LED from another, what do you calibrate the lux meter to? Or do you use two different lux meters, or how to do it?
Technically, I don't have an answer, but it's something that you should avoid as much as possible, because like the mix of the sources, you will mix like color temperature, like color rendering index, and won't be like a very like for the operations on the ground won't be very very good actually.
So engineer Cavallotti, are you saying they should upgrade the sodium to LED?
They should upgrade the sodium to LEDs as soon
I think we
as
should
possible.
swap jobs.
Yeah, I mean, we always suggest not to mix two sources for two reasons. One is at the beginning in the design, because it's hard for a designer to evaluate the influence of an existing system together with a new LED system. This is the first reason. The second one is that the effect on the ground will be a mix of colors and technologies, and there won't be, let's say, the best practice for an apron in particular.
Yeah. Look, let's call it a day, because I know people typically have busy schedules and they want to move on to next meetings and next calls. There are questions which are unanswered. We will have to basically tackle them by email and send across the responses to everybody, and we'll share, I think, Sophie, all the questions and all the answers to all the people on the call, correct?
We will, yes. We'll send out after we finish, we'll send out a recording, we'll send the presentation along with all the questions and answers and any of the other resources. So, and just quickly before we go, we offer training to anyone who wants to get a bit more in depth about this topic. If you'd like some of that training, let us know now and we will contact you. But thank you both for the presentation and Marco for answering all of our questions, and of course all of our wonderful attendees. It's been great having you here today, and I think we've really enjoyed this session and we look forward to doing more of these.
Very much.
Thank you, everybody.
Thank you all. Thank you for the great turnout, amazing number of people. We wish you a lovely day. Thank you for joining Webinar Wednesday by Midstream, and see you at the next one.
See you at the next one. Thank you, everybody.
Thank you. Goodbye.
Bye-bye.